of the Always Believe House. Oh, today we're going to continue studying exponential functions. Ho, 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 ho. And it's going to be F-U-N, fun, fun, fun. Ho, ho, ho. So let's get started. And a magical whiteboard appears. And let's review what we learned about exponential functions. Okay, we're going to write at the top of the page. Remember, an exponential function was y equals ab to the x power, right? ab to the x power. The a was the starting number, right? Or the y-intercept. This is where the graph starts off at, right? Your starting amount or your initial amount. The b is the common product. And remember, if the b is greater than 1, the graph looks like this and it had growth, remember? So if the b was greater than 1, if the common product was greater than 1, the graph went up. If the b was less than 1, the graph went down and it was called decay. Okay, and remember, your x-axis was a line called the asymptote. Okay, the asymptote was the line that the graph approached but never ever crossed. Okay, so your asymptote is where the graph goes down to and just stays there. It never ever crosses it. Now then, on the first problems, they're wanting to see whether it's linear, which is y equals mx plus b. If it's quadratic, it's y equals ax squared plus bx plus c. And if it's exponential, it's y equals ab to the x. Okay, those were the three functions that we talked about. If it's linear, it has a constant rate of change. If it's quadratic, it forms that parabola and the table of values is symmetrical. If it's exponential, it's going to have a common product to go up or down. So let's look at the first one. And let's get our zero number in here, okay? So if we go over by x's, we're always going up by 1, right? You see that? So it's not skipping values. So let's go down here. And if we go to here, we would add 6, but 9 plus 6 is not 27, is it? So if you look right here, I'm going to multiply by 3, I'm going to multiply by 3, and I'm going to multiply by 3. This is an exponential function, okay? Because the common product is 3 in it. Also notice if I go backwards, I'm going to multiply by 1/3, which would give me 1, wouldn't it? So this graph would be y equals 1 times 3 to the x power. And it would have exponential growth, wouldn't it? So this one's exponential. All we really need to do is see if it's exponential. I'm just trying to teach you a little bit more on this. On this one right here, add 6, add 6, add 6. If I were to go back to the zero term and go backward, I would subtract 6. And I would get -3, wouldn't I? So this would be y equals 6x minus 3. Okay? That would be a linear function, wouldn't it? And my pen is messing up, so let's keep going. Hopefully we can finish this. Number 3 is going to be exponential. And it would have growth, wouldn't it? Because of the 2. The next one. Okay, this right here is not an exponential function. This is actually cubic, okay, or it would be quadratic. But we haven't studied cubic equations. You'll learn about that in Algebra 2. Okay, right here, this is going to be linear in it. The slope is equal to 3, and the y-intercept is equal to -8. Then on the next one, the x is in the exponent power. This is going to be exponential. Okay, the y-intercept would be at 4. The common product would be 0.3. This would have decay, wouldn't it? Okay, let's keep going. Determine whether each function represents a linear, quadratic, or an exponential function. If it's exponential, it takes the form y equal ab to the x, where a is not equal to 0 and b's, okay? So this one right here, this is exponential. A is equal to 3. And b is equal to 2. I'm sorry, my pen's messed up. The next one is going to be exponential because the x is in the exponent spot. Okay, this right here, the a would equal to 4. That's the y-intercept. The common product is 0.2. This would have decay, wouldn't it? So let's just put decay here. Okay, this one right here would have growth, would it? Because the common product is 2. Okay, on the next one, this is mx plus b, isn't it? This would be linear. Okay, on the next one, this is an exponent of 2. This would be quadratic. Okay, actually it's not quadratic. It doesn't have an x in there, okay? Okay, let's go down to here. Now then on this one right here, put growth. This is important. If the problem has exponential growth, if it grows and you have a percent, you're going to do the percent. Let's do 100 plus the percent and make it a decimal. If it's decay, you'll do 100 minus the percent, and it's going to be, you're going to write it as a decimal. So let's look right here. The forest acreage is decreasing. That means it has decay by 2%. If it's decay, you're going to do 100 minus 2, and that gives me 98%. And that is a decimal is 0.98. That's going to be my common product. Sorry, my pen's messing up. Okay, this right here is our initial amount. So the equation is going to be y equals 4, 5, 0, 0, 0, 0, 0, parentheses, 0.98 to the x power. So 4,500,000 times 0.98, sorry this is messing up, 0.98 to the x power. Okay, determine the forest land after each of the following, after 3 years. So we're going to punch this into the calculator and make it 3, okay? And we're just going to punch it up there. So let's go to the calculator. We're going to calculate. So A, and it's going to be 4, 5, 0, 0, and then 3 more zeros, parentheses, 0.98, close parentheses, caret 3, or let's see, after 3 years? Yeah, after 3 years. So we're going to use the third power. So this will be after 3 years. Every year is going to add 1. Hit enter, and we get, this is an exponential function, or this is in, don't panic out, this is in scientific notation. So 4.23536, that E stands for times 10 to the 6. So you'd move the decimal 6 spots, okay? Why it does that, I don't know, okay? So it's going to be 4, 1, 2, 3, 4, 5, 6. You're going to add a 0, okay? So 4, 2, 3, 5, 6, 0. 4, 2, 3, 5, 6, 0. So 4, 2, 3, 5, 6, 0. That's how big the acreage is, okay? Did I do that right? 2, 3, 5, 3, 6, 0. 2, 5, 3, 6, 0. Sorry that it's doing that, okay? It should... Don't know why. Okay, but anyway, let's go to the 5th year. Now then, I'm going to show you a trick here. Hit the up button. Hit the up button again. Hit enter. And now then, I'm just going to change that 3 to a 5. So I'm going to delete, hit 5, hit enter, and it's 4.067. That E to the 6 means you're going to move the decimal 6 places. So 1, 2, 3, 4, I need to add 3. 1, 2, 3, 4, 5, I need to add another 0. 4, 0, 6, 7, 6, 4. And then another 0. 406, 406, 764, 406, 764, and then another 0. Now we're going to do 10 years. So we're going to go here, hit the up button twice, hit enter, and now I'm going to change the 5 to a 10. Hit enter. Notice it's getting smaller. 367, 683. 367, 683, and then add a 0. And then lastly, 20 years. So I'm going to go over here. I'm going to hit the up button twice, hit enter, and then hit the left arrow button, delete, delete, hit 20, hit enter, and now I'm at 300, 424, and I need to add one more 0. I need to move the decimal 6 spaces. So 300, 424, 300, 424, and add another 0. Okay, so you can see how the forest coverage is decreasing, and it's not decreasing by much because the The common to decay is 0.98. That's barely below 1. So it's not going down by much. Let's turn the page. A 15% loss. If it's a loss, we're going to do minus 100. So 100 minus 15 is 85%, and that's going to be 0.85. Remember, if it's a loss, you subtract 100. If it's you subtract 100 minus a percent. If it's an exponential growth, 100 plus a percent. And we're going to start with 10,500. So 10,500 parentheses 0.85 to the x power. Now then, I'm going to let you get these answers. You'll plug in 1, 2, 4, and 10, just the same exact way I just did. Okay? Just remember, percent. If it's an exponential growth, you're going to add the percent. If it's an exponential decay, you're going to subtract from 100. Let's go to the next one. Has a 2.5% decrease, okay? Determine the population after each year. So this isn't going to go down by much. So 100 minus 2.5, that's going to be 97.5%, which is 0.975. That's going to be our common product. This is our starting amount. So 292,950,000 parentheses 0.975 to the x power. Going to do this the same exact way. You're going to type in 1, 5, 15, and 25 and put down the 4 answers, okay? Remember, if it's an E whatever, just move the decimal that many places and then add zeros if you need to add zeros. This will probably be a scientific notation. Let's go to the next one. Same thing. This decreases 12%. So if it's a decrease, you're going to subtract from 100. You get 88%, and that turns into 0.88. That's going to be our common product, or letter B. This is our starting amount. So 25,000 parentheses 0.88 to the x power, and you're going to plug those numbers in. Remember, hit the up button twice. Plug them in. Go to number 15. It depreciates at a rate of 5%, so it goes down. So 100 minus 5 is 95%. Sorry about this, which is 0.95. So we're going to do 35,000 parentheses 0.95 to the x power, and we want 8 years. So you're going to do 35,000 parentheses 0.95 to the 8th power and write that answer down. Piece of cake. Haven't had a growth yet, okay? So if it grows, you're going to add 100, okay? Haven't had that yet. Okay, this and still is decreasing at 7%. So you're going to do 100 minus 7 is 93%, and the decimal of that is 0.93. That's going to be our B. This is our A. So y equals 58 parentheses 0.93 or to the x power, and you're going to use x equals 8. Sorry that the pen's messing up. And you're going to get that answer, okay? Is this going to depreciate every time? Okay, the next one, I'm going to let you do number 17 on your own. Number 18, though, it's increasing 5%. So if it increases, you don't subtract, you add the percent. So this is going to be 105%, and if you make that a decimal, it's 1 to the 1 and 500ths, okay? So that's going to be our common product, or B. Okay, so we're going to do y equals, the house starts off at 160,000, parentheses 1.05 to the x power. Write an exponential growth function to find the value of the home today. And it was 20 years ago, okay? So we're going to replace the x with 20. And I'm sorry, pen is messing up. 160,000, parentheses 1.05, and then we're going to have 20 years. Okay, so we're going to go to the 20th year. Go to number 19. This is decreasing, so you won't add, you'll subtract. So 100 minus 3.5, that's going to be 96.5%. Make that a decimal, 0.965. That's going to be our B. Okay, and then it starts off at 2,500. So 2,500 parentheses 0.965. Sorry, this is messing up. 965 parentheses, and we want 5 years to the 5th power. You won't type that in, okay? Piece of cake. So the main thing you learned today, let me turn this screenshot off. The main thing you learned today, when you have percent in an exponential growth, if it's growing, you do 100 plus the percent, change it to a decimal. If it's exponential decay, if your number's getting smaller, you'll do 100 minus the percent, make it a decimal, and then that's your common product, okay? Piece of cake. These are real easy problems. Have a wonderful time doing them. It's going to be just like eating Oreo cookies. Oh. Remember, you are amazing. You are created to do wonderful things, and you are awesome.